Hey guys, so this is meant to be a supplement to your lesson number 2, and I just wanted to go over a little bit about how to find the roots of a polynomial and how it's related to its graph. So take a look at this example here. I have x cubed minus x squared minus 6x, and it says what are its roots? So normally when we want to find roots, we are looking for the x-intercepts, which is when y is equal to 0. So what you want to do is set the whole thing to 0, and you can try and solve it by factoring. So I'm going to do that. Very first thing I notice, and the first thing you should always look for in a factoring problem, is whether or not there's a GCF. In this case, I see there is. The GCF that all these terms have in common is x. So I'm going to factor that out. That leaves me with x squared minus x minus 6. Now you can use your factoring shortcut here. You ask yourself what would multiply to negative 6, but then add to negative 1. The answer to that would be a negative 3 and a positive 2. Now the final step in actually figuring out what the roots are for this polynomial would be taking each part and setting it to 0 and solving it. When I take x and I set it to 0, I just get 0. When I take x minus 3 and set it to 0, I get x equals 3. And when I take x plus 2 and set that equal to 0, I get negative 2. So I should have 3 different roots at 0, 3, and negative 2. And you can check this by graphing this in your calculator. Just to show you what it looks like, I've made a little drawing down here. All right, and you can see that right here at negative 2, x equals negative 2, there's a root. Right here at x equals 0, there's a root. And over here at x equals 3, there's another root. So there's something definitely very special going on there. And what it is that if you can identify the roots of a polynomial, you can pretty much write its function from those roots. Now sometimes there might be something else that you would multiply by, like a vertical stretch factor. You know, it could be like if you had a 5 in the front, then it could be vertically stretched by 5, so it would have the same roots, but it would be a lot taller and skinnier kind of looking. But generally, if you have the intercepts of the graph, then you can write the function. So if I were to come up to this and just look at it, I would say, oh, okay, if I'm going to write a function for this graph, I know I have a root at negative 2. So in a binomial, that would look like x minus negative 2. All right, also known as x plus 2. At 0, my root would be x minus 0, or just x. And then at 3, my root would be x minus 3. Ooh, running out of space here. And if I kind of rearrange these, you can see how this looks exactly like what we just factored. So x and x plus 2 and x minus 3. So you can use the picture with the different roots to actually write a function for it. Here's a question, different question. And the question is, if you have a function and it has roots at negative 5, 8, negative 13, and 1, what function could you write for that would have these roots? So do exactly the same thing that we just did, work backwards. So from here, I would say it could have a root shown as a binomial of x minus negative 5, of x minus 8, of x minus negative 13, and of x minus 1. And I'm just going to simplify these. So the equation for that would be x plus 5, x minus 8, x plus 13, and x minus 1. And I can guarantee you, if you were to plug this into your y equals in your calculator and actually look at the graph of this, it would have a root at -5, +8, -13, and +1. The last thing that I wanted to review with you is how to factor by grouping, which is a skill that you're going to need in order to do this assignment. So let's just say we have a polynomial f of x, and it is 3x squared plus 6x plus 4x plus 8, just as an example. And sometimes we see these as actually having like a cube, then a squared, then an x, then no x at all. This is a different example, but it's factored the same way. So when we factor by grouping, you generally want to split it down the middle. And you want to try and take the GCF of this side and then this side. So I'm looking at these and thinking, what can I take out as a GCF? Definitely a factor of 3, and also a factor of x. All right, if I do that and I divide those out, let's see, 3x squared divided by 3x is just x. 6x divided by 3x would be 2. I carry down this sign, and I look for a GCF from these. What goes into 4x and into 8? Well, 4 goes into both of those, and I actually don't have an x that I can take out, so that's it. When I divide those out, 4x divided by 4 is just x. 8 by 4, 2. You know you did it right if these match. You know you did it right if these match. So you can take these out as a GCF. And then these are what are left over. Okay, so I could use these to actually determine the roots of this original function. All right, if I wanted to do that, I would set them to 0. X plus 2 equals 0. 3x plus 4 equals 0. From here, I would get x equals -2, so I know it would cross the x-axis at -2. And then from this one over here, I could subtract 4. And then divide 3. And I would get -4/3. And if you were to look on your graph, you would see that at -1 1/3. So those are the two roots for this polynomial function, and that is just a short review of factor by grouping.